yesterday. So yesterday's class only has the Zoom recording. But I'll try to make sure I record it. Recently, recap will take like 20 minutes if I have to do it. So I'm happy to do it though. Um, Business standard no, they didn't feature us. It was for Karan. He needs a publication for his O1. So that was done for that. Like you need to, there are a few requirements for an O1. One of them is it's a good thing if you have, a news publication cover you, akhbar maybe and online. So that was why that was done. They didn't really cover us. All right. How to reduce your age? I don't know. Haven't figured that out yet. Are we focusing on Next.js and Node.js? That's not the worst thing to do. I don't think if you have done that. I think we have focused less on Next, if anything. There are a lot of topics pending in Next right now. But it's not the worst thing to do. Most companies are hiring for Next.js engineers only. Node.js, at least in Super 30, मैं सोच रहा हूँ कि Next.js has been the stack, or Python has been the stack. So, not the worst thing to know Next.js, even though I know it's a high level of abstraction, but still. Cool. Would we build a notification system? We might. I don't know what advanced projects we have, but we'll build something similar. If you understand that similar thing, you'll understand how to build a notification system. Like worst case, we can build one as well. It's not that difficult. Might be good if we build that in Python plus Celery though. I've recently been, spending a lot of time building those projects, like building in the Fast API plus Celery stack, and I don't hate it. Especially the distributed task, basically Celery and whatever it provides is super cool. And I don't know why Python is the only language that people use for Celery, like while dealing with Celery. They have clients in Rust. I've had discussions back in the day when we were trying to architect a system. Should we use Celery or should we use Redis? And then we ended up using Redis. But it's a beautiful technology if you go through it. All right, are we at 8:04? We're at 8:04. 8:03, but we can start. Let's kick things off, guys. I'll do a quick recap, okay? Nothing to basically not cover this in 2 hours of what we did yesterday. I'll try to cover it in 20 minutes. I'll try to cover what we did yesterday. The goal of this week was containerization / Docker. What was the goal? It was containerization / Docker. And yesterday, we covered, these are the slides, by the way. Let me post them in chat. Yesterday, we covered everything from step 1 to step 14. So let me take you through each one of them very quickly. Okay, what did we cover yesterday? And then we'll get into some slightly advanced Docker concepts. The first thing we covered yesterday was why do you need Docker? What does it provide? Even if you don't know the internals of Docker, uska fayda kya hota hai? Why do most people prefer it? Why do most people create a Docker file or use a Docker file is the first thing that we learned yesterday. इसका रीजन मतलब मोटा मोटा ये होता है कि इफ यू हैव टू build any full stack application where you want a lot of contributors, it is good to containerize it because जब भी कोई नया developer team को join करेगा, whenever a new developer joins a team, they can run the project in a single command. Yesterday we also saw a project called P5JS Web Editor, which had 2 ways to set up the project: the easy way, which was using Docker, and the harder way. So what is the first thing that Docker provides you? Easy way to set up projects locally. Easy way to deploy them across various environments. Today, you might be using EC2. Tomorrow, you might move to DigitalOcean. In the third, you might move to GCP, then Vultr. You might change clouds. So Docker is sort of OS agnostic. You can run it on any operating system. One of the good things it provides is, okay, if you have even a fresh machine, let's say you have a fresh Windows machine today, and you want to run a full stack project like cal.com. So you don't have to install pehle Node and then, Postgres and Redis, whatever dependencies that they had. You don't have to install all of that. You just have to install Docker. And then you simply have to run something like docker run cal/cal.com, a command like this. And this will internally start Postgres, Redis, Node.js, the Node.js process, the Next.js process. Everything it will start together. Today, we will build a Docker compose file that will show a little bit of how this is done. So what are the benefits of containerizing your application? What are the benefits of Docker? if you are using Docker in your full stack project, abhi tak monorepos bana li hai, we have built monorepos, and doesn't matter if this is this stack or a different one, even if you're using Rust, even if you're using Python, even if you're using Java, it's a good idea to containerize your application. Why? Easy to deploy it everywhere, easy to share it with your friend, it'll run on his machine like this, and isolated from the host machine. What does isolation from the host machine mean? If this is your Windows machine, and here you want to run something, so you can either run it directly, node index.js. When you do that, it is running directly on your Windows machine. A 3000 port over here is captured by this index.js process. This index.js process can read your file system. If I write code like this, fs.read file a.txt, it can read everything in my host machine, my main Windows machine. But if I run it inside a container, if I run docker run index.js, let's say, it's a wrong command, but let's say I run it, then a container starts, jiske andar node is already installed and node index.js runs here. So if now this JavaScript file tries to do something notorious, tries to read the file system, it will read the file system in this container. It will not read the file system of my host machine. You can run it in isolation. That's the other benefit of using Docker. Generally, every app that you're creating, create a Docker file for it. If it is a monorepo that has multiple projects, create multiple Docker files for it. And in your README docs, share, okay, this is how you can start the project using Docker. The same we saw yesterday for processing/p5.js web editor. Okay, if you go to their contributor docs, and click on the installation section, they give you two ways, manual installation and Docker installation. So this Docker installation hai, this is what we are learning today. Okay? Given you have created a project like this, how do you create Docker files for it? How do you containerize it? How do you make it easy for anyone to set up your project? For example, if you're using Docker installation, then you just have to run one command. If you are using manual installation, then you have to do this, install Node.js in your machine, then install whatever, MongoDB you'll find somewhere, install MongoDB on your machine, copy the env file, update the env files, 10 different steps you have to do. If you use Docker, one step, good to go. Great. Then we understood what exactly is containerization. Containerization hoti kya hai? Long story short, you have a big machine, you can run mini containers inside the machine. It is not similar to a virtual machine. You are not starting a full ass virtual machine on your Mac. You are starting what are called containers. They are much more lightweight. If you start a container locally, like we did yesterday, or let me show you, this is one way to start a container, Docker, run Mongo, and notice it starts almost immediately. I have started a container, but it took less than 1 second to start. If I want to start a virtual machine, कि मुझे अपने Mac machine पे Windows खोलनी है, if I want to start a Windows machine inside my Mac machine, that takes 2 minutes, 3 minutes to boot. Containers start instantly. They're much more lightweight compared to a virtual machine. History of Docker, which is not really important, but it is a company, it makes money somehow. How do you install Docker locally? Would urge you to do this. How do you know if you have Docker locally? If you run the Docker command, you should see an output that looks like this. If you don't, if it says Docker does not exist, that means you have not installed Docker locally in your machine correctly. So make sure Docker is installed. Then we understood a little bit of internals of Docker. What is the Docker engine? What is the Docker CLI? What is Docker Hub? I would urge you to go to yesterday's class and go through it. Let me give you a very quick 2-second TLDR. Okay, whenever I run this command, Docker run Mongo, what happens is I have the Docker engine running locally. What do I have running locally? When you install Docker, what starts? A Docker engine starts. This CLI is just a way to interact with the Docker engine. You can also interact via an HTTP request. You can also send a request to some docker.socket/API/v1/start/container/name/Mongo. You can also send an HTTP request over here. This also does the same thing and lets you talk to the Docker engine and start, let's say, MongoDB locally. That is the Docker engine. Then we understood the Docker CLI. What is the CLI? Command line interface. Basically, this command that you see over here is the Docker command line interface or the Docker CLI. And lastly, we have Docker Hub, which is similar to GitHub. The name itself is giving it away. If I go to hub.docker.com/_/Mongo, this contains the MongoDB image. What is an image we'll come to? But this contains the MongoDB image. What is an image we'll come to? Same cheez do baar boli maine. And similarly, there is the Postgres image that is stored over here. There is the Redis image that is stored over here. When you go to GitHub, if you want to see Redis code base, what do you search? Redis GitHub. And it gives you the code base of Redis. This is the actual source code written in C, C++. This is an image for Redis. What is an image we are coming to? But यहाँ पे images host होती हैं. ये भी sort of Docker का part है कह लो या one important part in Docker. Whenever you run, for example, if I run Docker run Redis, I'm trying to find an image that I don't have locally. MySQL. If I run Docker run MySQL, what does it say? Unable to find image MySQL locally. So it gets it from somewhere. This pulling from somewhere. It's similar to cloning a repository. Where is it getting it from? It is getting it from here. So what is this thing that you see on the screen? This is a registry, just like GitHub is a registry for storing source code. npm.js is a registry for storing JavaScript libraries like Express. So if I go here, I can see the page of Express. If I click on code, I can see the code base of Express that comes to my machine when I run Docker npm install Express. And similarly, this is the Docker Hub registry where Docker images are pushed, which begs the question, what are images and what are containers? So this was also fairly simple. Okay, you can see this locally. Okay, when I run the command Docker images, it tells me I have a Redis image. It tells me I have a Mongo image. It tells me I have a Postgres image and a bunch of my own images that I created. This can be my own projects that I'm building. These can be open source projects. If you compare this to source code, जब आप Redis का code copy करते हो, it comes to your machine. If you copy the MongoDB open source code base, it comes to your machine. Similarly, I have gotten images of Redis, Mongo, and Postgres locally. If you want to see it on your machine, just run docker pull Mongo. It will pull the MongoDB image to your machine. Containers is when you actually start an image. I repeat, there are two things, images and containers. Very nice visualization would be here. Okay, the Docker registry contains images. People have pushed official MongoDB image here. When you on your Mac machine run the command docker run Mongo, you pull this image from Docker Hub. You start that image in what's called a container. So ye blue cheese, this is a container. This is an image. Image is stored where? In a Docker registry. Similar to, this might be GitHub. GitHub stores the source code of Redis. I can clone the source code of Redis and then I can start it. Cloning, that thing is the image. That thing is the source code for Redis. Starting it is when you are actually starting the process, when it is actually executing. So what is a container? A container is a running instance of an image. It is an image in execution. So when I run docker run Mongo, what did I run? Docker run Mongo. I started a container. What image is the container using? The Mongo image. So if I run the command docker images, it shows me I have all of these images, one of them being Mongo, one of them being Postgres. If I run docker ps, it shows me I have two containers running. What do I have running? Two containers, some random container that I started a while back and a Mongo container. So I just started the Mongo container here by running docker run Mongo, and I can see it is actually running when I run docker ps. Let me kill all of these. Let me kill the first container I have running locally. Let me kill the second container I have running locally. And now I have no containers running. I still have images. When you clone a code base, it remains in your machine, right? If you start it, it is running. If you stop it, it has stopped. Similarly, just making sure it's recording. Similarly, you can pull an image, it will stay in your machine. You can start the image by running docker run whatever. Cool. Great. That's images versus containers. Then we understood about something called port mapping. So yahan thoda, let's get a little hands on and try to understand port mapping again really quickly through running MongoDB locally. Abhi tak, if you run MongoDB locally by running this command docker run Mongo, you will face issues. This will basically not work. If I go to MongoDB Compass if I open the MongoDB GUI and try to connect to this container, what have I done? I have started MongoDB locally. How did I start it? I started it using Docker. But is it running? It is running. But can I connect to it? No. I can't connect to it right now. How can I confirm? If I open MongoDB Compass, if I try to connect to MongoDB / localhost / 27017, which is where by default MongoDB starts, I will not be able to connect to it. If I try connecting, it says connection refused. Why? Because even though I started MongoDB, I did not expose MongoDB. Exposing comes via port mapping. So what was port mapping? What did we discuss yesterday? Here, whenever you are starting MongoDB, in the MongoDB container, something is exposed on port 27017. But in your Mac machine, nothing is exposed on 27017. The containers don't really take your main Mac machine's ports. The containers start a small mini machine. That mini machine has its own port range. And over there, yahan pe the process is running on 27017. If you want to expose it on the host machine, if you want to make sure MongoDB can be reached via the Mac machine, then you have to add a port mapping. You have to add a port mapping. Yaar, I want to run MongoDB, but I want कि my host machine's port 27017, मेरी Mac का port 27017 should point to the container का port 27017. What have I added? I have added a port mapping. What does this do? कि अब मेरे Mac machine का ये port, this port on my Mac machine is forwarding requests to this port of the Mongo container. If I try to connect over here now, it works. Why? Because Mongo is now exposed on my host machine. If I just run Docker and Mongo, a container starts, it has its own port range, wahan pe it is exposed. I can't really reach it from my Mac machine unless I add a port mapping. So that was what we learned during port mapping. Then we understood some common Docker commands. I've already shared them, but Docker run, Docker ps, Docker kill, Docker RMI, Docker build, Docker exec. So go to yesterday's class if you don't know these very simple commands. Docker build is the most important one here. The rest of the slides would revolve around this Docker build command. What does Docker build do? It lets you create an image. Abhi tak, we have been using other people's images. Mongo is an image that was written by the founder of MongoDB, maintainer of MongoDB. We did not write it. What if I write my own database? I want to create my own image and push. So there you have to build an image. You're supposed to create an image that you can push to Docker Hub eventually. That is where the Docker build command comes. Yesterday, let's see if I have it. Yesterday, we created a very simple Node.js project. If you look at the Node.js project, it looks like this. Oh. A simple Express server. It has a single route handler. Anytime a request comes to / rest.send hello world. If I run this normally, node index.js, so now this process is running on port 3000. I can see hello world on the screen. This is my simple backend Node.js project. But if I want to containerize this now, how will I containerize this process? How do I create an image for it? How do I make sure I can send it to a friend? How can I publish it to Docker Hub? Here is where we understood about the Docker file. Okay, most projects that you're going to write, abhi tak to we learned a bunch of abstract things. The actionable thing that you have to do is learn to write Docker files. Learn to write a bunch of steps that are needed to start your project. This is my project. This is not MongoDB. This is my own HTTP server. I can write my own database. So after I have written my source code, the last one thing I have to do for containerizing it is creating a Docker file. What is a Docker file? It looks something like this. It has a few constructs. The first one is from. Okay, what is your base image? कहाँ से आपको start करना है? It is a good idea कि अगर आप Node.js process बना रहे हो, if you are containerizing a Node.js app, start from a base Node.js image. What is a base Node.js image? basically mongo.com, or hub.docker.com/_/node. This is the base Node.js image. मतलब क्या है कि it has an operating system, it is a mini machine, but it also has Node.js already installed. That is the benefit of using a Node base image. What is 22? The version of Node.js that we are using. What is Alpine? It is a slightly thinner Node.js image. I could just write Node 22 also. That will be a slightly fatter image. But if I choose Node Alpine, all Docker images have Alpine versions, which are slightly thinner versions, which is recommended or a good thing to do because your images will then be smaller. So the from command, you can start from scratch also. You don't have to necessarily, start from a base image, but generally, if you have a Node.js project, you start from a Node base image, जिसमें Node.js already installed है. If you have a Golang project, you start from a Golang base image, so on and so forth. Harkirat, what if I have a Node and a Golang project? And then you find an image that has both Node and Golang. Or you start from Node and then you write steps over here to install Golang, whatever the command might be, go.install.com/install.sh. Whatever the command might be to install Golang, you can write it afterwards. Start from Node.js, install Golang. Agar dono chahiye. But our project only needs one Node.js. So this is our base image. This is our working directory. What does working directory mean? Okay, where should the code be stored? Where should the code be copied? There are a few options. You can put whatever you want here. If you want to put Harkirat here, you can put Harkirat. /app is just a popular place to put your code inside the image. What are we building? We are building something where people can come and run our image. When they run our image on their machine, a small container will start. A small mini machine will start. And that mini machine's app folder is where I want to put the source code. That is what. This is the Mac machine of the user. This is the container that they will start eventually when they run my image. /app is the folder jahan pe we want to copy the source code. That is what workdir means. Copy ... means copy everything from this folder into the image. What does copy ... mean? I can also write copy ./index.js to ./index.js. And then copy ./package.json to ./package.json. Or I can say copy everything. Copy everything from here over to my image, over to the thing that I'm creating. Run lets you run a bunch of commands. In this case, since this is a Node.js project, मैं code तो copy कर लूँगा. I will copy the code, but my code might not have node modules. In fact, we have explicitly added node modules to Docker ignore. कि इसको ignore करना, इस folder को ignore करना, इस folder को copy मत करना. When I copy, I don't copy node modules. Why? Because I've put them in .docker ignore. Why? Because whenever you are creating a Docker image, you should fresh install dependencies over there. You should not copy your host machine की dependencies. ये dependencies Docker image में नहीं जानी चाहिए. Only your source code should go into the Docker image or the Docker container that will eventually start. उसमें you should fresh install the dependencies. That is what this command does. We know our process is going to expose a port 3000. That is what this command does. Command is the final command that will run when the person starts the image. All of this is when this person creates an image. Last command is when the person starts the image. These commands run when you're building an image. This command runs when you're starting the image. What does building an image mean? Just running the docker build command. For example, docker build, tag the build with 100x devs /class2, a name for it. You can name it whatever you want. You can name it, my node project. And where is the source code present in the current folder? That will build the image. What does building the image mean? It means ये सारे steps one after the other run हो रहे हैं. Everything from here to here is getting run to create sort of a bundle, to create sort of an ISO file, to create an image that people will eventually run. Image में क्या है? Image has your file system, has all of your dependencies, has Node.js, has your source code. Image knows कि जब image start होगी, so this is the command that needs to run. All of this is getting packaged. What is an image? It is a package that has everything. That is what gets created when I run the docker build command, the name of my project, the folder where it is present. And then there is the docker run command. What was the name of my image again? It was my node project. ये build हो गई है. This image is now in my machine. It is in my machine. It is not in your machine yet. I have not pushed it to Docker Hub yet. But it does exist in my machine. If I run Docker images, I can see My Node.js project was created about 54 seconds ago and has a size of 159 MB. So I created this my node project image. To run the image, to start the container, I will run the command docker run my node project. But does my node project expose something on port 3000? Yes, Harkirat. So do I need to add a port mapping, the thing that I discussed a few minutes ago? Since the container runs something on port 3000, I need to expose it via my host machine, where I won't be able to visit my website. That is what this port mapping is now adding. Same as MongoDB. थोड़ी देर पहले what did we do? We ran docker run port mapping 2717:2717 Mongo. कि Mongo जब start हो रहा है, Mongo will start by default here. The host machine का ये port should point to the Mongo machine का ये port. Same thing I'm doing here. Okay, I want to run this image. I want to add this port mapping. My machine's 3000 port will point to the container's 3000 port. I run it, and now I have started a containerized Node.js project. I have been able to containerize my simple Node.js project. This is a very simple project. It has one file, but steps don't change too much. If this is a TypeScript project, something extra will get added. If this project has Prisma, something extra will get added. Your Docker file will change a little bit. If this has a monorepo, then a few things will get added. But the most simplest project ke liye, the Docker file looks like this. To recap, the base image, the working directory, copy the source code over, run npm install to install all the dependencies inside the image, expose a port, and the final command that runs when the image starts. I repeat, this command runs when the image starts. These command runs when the image is being built. So when you're building, when you run docker build, when you run this docker build command, everything from here to here runs. When you run the docker run command, then this last command runs on that image. This is all that we discussed yesterday. One extra thing we discussed, how to push to Docker Hub. Very simple. So just go to yesterday's class and go through it. Is there anything that's missing? One more quick thing, let me show you. I have this container running now. If I go to localhost colon 3000, I see hello world. If I look at Docker PS, I see an image is running. A container is running. I can go inside this container and see kya ho kya raha hai andar. What does the file system look like? For that, the command is docker exec. I want to execute a command. I want to execute it interactively on this container ID, and the command is sh. What will this do? This will give me shell access to my container. This is my Mac machine, but now I am inside my container. Notice I'm in the /app folder, my working directory. If I press ls, I see index.js, which I copied from here to the container. I see package log, I see package.json, I see Docker file. And I see node modules, which were not copied from here. They are in the Docker ignore. So they weren't copied from here. They were actually added when npm install ran. So if you actually look at the logs of Docker build, you will see a lot of things. When you see the logs of Docker build, it tells you, okay, some things are happening. Transferring Docker file 136 bytes, loading metadata for the base image. कि this base image we got from somewhere. अब तो मेरे machine में आ गई है. So it loads its metadata, runs the from command, which is this thing right here, the base image, runs the workdir command, which is this thing right here, runs the copy command, which is the third command right here, runs the npm install command, which is the fourth thing right here. Expose, it doesn't have to show it over here, or that isn't a layer, that doesn't add a layer. What are layers we're coming to? And then finally, ये run नहीं होती है. When I run docker build, notice there is no fifth step that says node index.js because I'm building the image. I'm not starting it. CMD में जो लिखा है, that runs when you start the image. So building the image is running everything from here to here. Starting the image is running the last thing. So when I run the image, then node index.js runs. I already have the container running here, which is why I wasn't able to start it. There was a port conflict. But if I start it, that specific command runs. तो ये सबको समझ आ गया? If this is clear, then we can move on to layers in Docker next. But do we understand this good to go? वैसे not good to go, तो we will proceed only because this was covered yesterday. 90% understood. So I'm hoping this is simple. No need for a poll either. Let's get into today's class. Today, we're supposed to learn everything from layers in Docker to Docker Compose. Slightly more advanced concepts, nothing too complicated. But after you write a Docker file, it is a good idea to optimize your Docker file. It is a good idea to containerize all the services your application needs, be it Postgres, Redis, MongoDB, Node.js. So we'll understand how all of that happens. Okay? So now we're actually starting today's class. The recap is done. I'm hoping it was straightforward. If not, yesterday's class is fairly comprehensive. You can go through yesterday's class and try to understand it. Cool. CMD access, you are not starting, it doesn't have Windows, the container that you're starting. So, there's no way to get CMD access. But yeah, if you are starting one, then, whatever is the command that is needed to start CMD, just go to your Windows prompt. However you open CMD, same way you can open CMD in there. Even though I have never heard someone, or I don't even know if you can create a Windows container. I might be wrong. All right. At least from a Linux machine, probably you can't. Okay. Layers in Docker. What are we discussing today? Layers in Docker. Sort of like an onion. What does this onion have? It has a bunch of layers. This is layer 1. This is layer 2. This is layer 3. Can we say that this layer is sort of built on top of the smaller layer? Sort of. क्या मतलब, ये इसके ऊपर बनी हुई है, ये इसके ऊपर बनी हुई है. One after the other, layers are getting added. What are layers in Docker? Layers are a foundational or a fundamental part of the image architecture that allows Docker to be efficient, fast, and portable. They have written Docker in a way that whenever you build an image, you are actually creating a bunch of layers. One image on top of another image, on top of another image. We were already doing this here. This was the base image. This was ये center वाली image. Then उसके ऊपर I was running the workdir command. That is another image that is created on top of the existing one. थोड़ी सी और extra चीजें हैं उसमें. Then we copied the source code. That is the third image. Then we ran npm install. That is the fourth image. These are the only 4 commands here that would create new layers. Expose does not create a new layer. This does not even run when the image is being built. So there are 4 layers in our Docker image. The base layer plus the working directory, the base layer plus the working directory plus the source code, base layer, working directory, source code, and npm install. So these are the 4 sort of layers that we have been created. As your Docker file becomes more complex, you might have 5 layers, 10 layers, 20 layers, depending on कितने steps आपने यहाँ पे लिखे हुए हैं. इसकी जरूरत क्यों है? Why do you need layers? And one of the biggest reasons is caching. How are layers? Let's go through this also. जो भी लिखा है ये. How are layers made? There is the base layer, a starting point of an image, which typically is either an operating system like Ubuntu or a Node.js base image or a Golang base image. That is our first layer, usually called the base layer. Then there are instruction layers. Each command in a Docker file creates a new layer in the image. These include commands like run or copy, which modify the file system by copying packages, installing packages. All of these commands that we're running, copying the source code, running npm install that will create the node modules folder, is creating a new layer on top of the existing layer. Q we're coming to very soon. The third point is why you do this. Reusable and shareable. Layers are cached and reusable across different images, which makes building and sharing images more efficient. If I today create a new project that also uses Node 22 Alpine, then this cached layer that I already have on my machine can be used by both the projects. I don't have to re-pull Node.js 22 for my second project and then the third project. What is the benefit? Each of these layers are independently cached. तो अगर एक और project को ये base image use करनी है, if a different project wants to use this base image, they can. This isn't the biggest benefit. We're coming to the biggest benefit very soon. This is one of the benefits. That base image at the very least is cached. But all subsequent layers are also cached. This is a very common interview question. Okay, why do you need layers? Iska benefit kya hai? We're coming to that very soon. Immutable, they cannot be changed once a layer is created. It looks the same. You can't really change it. If you are changing it, then you're creating a fresh layer. So, what is the point of this slide? Docker has something called layers. Uska main benefit kya hai? We have not yet discussed. Why do you need layers? But you will notice that when I was running Docker build, it was giving me some sort of steps. 1 of 4 base image आई, 2 of 4 working directory आई, and कुछ लिखा भी है यहाँ पे cached 2 of 4, cached 3 of 4, cached 4 of 4. So are these the 4 layers of our Docker file? Yes, indeed they are. The base image is the first layer. Base layer plus working directory is the second layer. This is the third layer and this is the fourth layer. Benefit abhi bhi nahi samajh aaya. What is the benefit of this? Still did not understand. But there is something called layers and we can clearly see them in the docker build command. Okay? For our current Docker file, it is creating 4 layers. I can do something more complex here. I don't know, npm install -g yarn. Let's say I install the yarn package manager. And now how many layers will I have? I will have 5 layers. If I run docker build now, it failed. But as you can see, 1 by 5 was the first one. And then second was cached. Third was not cached. And then this sort of failed. We'll come to why third wasn't cached. It's actually a beautiful question. Third layer क्यों cache नहीं हुई? We'll come to soon. All right. Because answer is because we changed the Docker file. But you did not change the source code. फिर भी हो गया. जिनको पता है उनके लिए छोड़ दो बाकी लोग. Cool. Layers in Docker थोड़ी थोड़ी समझ आ रही हैं. जैसे जैसे this becomes more complex, we have more and more commands. We have more layers. Why is the question. Here comes the concept of there you go. By layers. If you change your Docker file, layers can get reused based on where the changes was made. This is the answer to why do you need layers, or what is one of the biggest benefits of using layers locally. वैसे तो there are benefits when you are pushing to Docker Hub also, but locally जब आप किसी Docker image को build कर रहे हो, let me revert this. When you are building this Docker image, what command did we run? We ran docker build. This was the command that we ran. What are the steps that ran? Base image, working directory, copy the code, npm install. Now, when you are a developer, you are changing code every day. In fact, when we eventually push this to GitHub, GitHub will build this and push this to Docker Hub. We'll write a CI/CD pipeline for it. So every commit, every change, you will rebuild the project. Let's say I change this from hello world to hello world 2. Now, if I rebuild the image, notice it takes a longer time. Why? It did not take very long, I say. Did not take very long, but assume it took long. Why am I saying assume it took long? Because as you can see, layer 3 and layer 4 are no longer cached. For some reason, layer 1 is cached, layer 2 is cached, layer 3 and layer 4 are not cached. If there is a layer that says cached, इसके means इसके ऊपर वाली तो सारी cached होंगी ही होंगी. All the layers above it are cached. All the layers below it may or may not be cached. यहाँ पे अगर cache चला गया तो इसके नीचे वाली will never be cached. Whenever you are creating layers, you can create the first layer and then there might be a bigger layer on top of it, and then a third layer. And then a fourth layer, let's say. If this layer changes, then all the above layer will also become uncached, because the second layer depended on the first layer. अगर यही change हो गई, if this changed to something, then this will also change, this will also change, and this will also change. What do I mean it will change? I mean कि आप reuse नहीं कर सकते. अगर आप 2 बार docker build कर रहे हो, if you ran docker build once, let's say, these were the 4 layers that were created. Then after 5 minutes, you made no changes and you ran docker build again. Then all of these cached layers will come. कि ये तो हमने अभी किया था 5 मिनट पहले. We did this 5 minutes ago. And then these same layers will get copied because we already have it. But if between these 2 builds आपने code बदल दिया, if you changed the file a little bit, if you changed this from hello world to hello world 2, तो क्या ये layer change हुई? Did the first layer change? Not really. First layer has nothing to do with the index.js file. First layer is not even dependent on index.js. It is a base image that comes from somewhere. So this layer can be cached. That means between this first Docker build and second Docker build, base image तो cached ही आ गई. Then we ran workdir. That was the second layer. That also doesn't really change between the builds. Between this first build and second build, index.js file changed, source code changed. उसका working directory पे क्या ही फर्क है? We are just creating an image whose base image is this, working directory is this. Nothing changed. Copy. Now something changed. Between this first build and this second build, now you are copying a slightly new file. ये जो third layer है, इसमें कुछ नया है अब. This third layer you can't really bring from here to here. You can't use the cached layer. क्योंकि इसमें in the third layer index.js looked different. And here in the third layer index.js looks different. Since index.js changed, the outer layer or the third layer over here changed. That is exactly why when we looked at the logs, only the second layer was cached, third layer wasn't cached. Why was the third layer not cached? क्योंकि फाइल चेंज हो गई, राइट? डॉकर इमेज क्या है? ये लेयर्स क्या है? दिस इज द Node.js बेस इमेज, दिस इज द Node.js बेस इमेज. ये तो सेम ही है दोनों की दोनों बिल्ड्स में. दिस इज द fact that the working directory has been changed to app. This layer has the fact that the working directory has been changed to app. This also does not change at all between builds. The third layer, this layer has index.js, जिसमें the code says rest.send hello world, and this has index.js which says rest.send hello world too. So that is why you can't just reuse this third layer. You have to rebuild the third layer. तीसरी layer फिर से बनेगी. That is why the third layer here is not cached. And if this layer becomes uncached, then everything that comes after it also becomes uncached. That is why the fourth layer here is also uncached. Benefit क्या है caching का? कि step 1 and step 2 happened like this immediately. But step 3 where index.js was changed, of course took some time because copy करनी पड़ी नई file. Step 4 of course took some time because npm install can take a lot of time if you have bad internet, slow internet, or if you have a lot of dependencies. In our case, we do not have a lot of dependencies, just one dependency did not take a lot of time. तो ये benefit होता है layers का. क्या benefit है layers का? कि आपका अगर project है, if you have a simple express application where you are changing code and rebuilding the image, 2 layers are getting reused. पूरी की पूरी एक बारी में नहीं बनती है. The whole image doesn't get created once. It gets created in layers ताकि internal layers can somehow be cached and outer layers, if they change, chalo, we will rebuild them. So what happened now when I changed the source code? Up to the second layer was cached, everything else is uncached. What will happen if I rerun Docker build again without changing the source code? अगर मैंने फाइल नहीं चेंज करी, then तो all layers can be cached, right? कुछ चेंज ही नहीं हुआ दोनों बिल्ड्स के बीच में. पुराना बिल्ड और करंट बिल्ड इज द सेम. डॉकर इज स्मार्ट इनफ टू फिगर आउट कि अच्छा दिस कमांड में नथिंग हैज चेंज्ड, दिस लेयर इज आल्सो कैश्ड, दिस लेयर इज आल्सो कैश्ड. सो इफ आई कैन कीप रनिंग डॉकर बिल्ड अगेन एंड अगेन विदाउट चेंजिंग द सोर्स कोड, एवरीथिंग इज कैश्ड. इफ आई चेंज द सोर्स कोड, देन ऑफ कोर्स व्हेन आई रन डॉकर बिल्ड, only 2 layers are cached and layer 3 and layer 4 are no longer cached. What is that doing? That is just making these 2 steps a little bit slower because नई image बनानी पड़ रही है. New image layers need to be created on top of the same 2 existing images. Original 2 layers same है. These layers are remaining the same. Outer 2 layers are changing because index.js is changing. Do we understand this? If you understand this, then there is an assignment that, a common assignment that you will see. But do we understand this much? The concept of layers? Docker does not create a single image, it creates a bunch of layers, which is in the end called an image. And why is this done? So that caching बढ़िया होती रहे. Beautiful. Okay, समझ आ गया. तो great, 92% is beautiful. I thought I was going fast. That's pretty good. Took us 15 minutes to understand layers. Beautiful. So if we understand layers, so how many of you already know what's wrong with this? Let's do another poll. Let's see how many people already learned this, already know this. Do you know the common flaw in here? If someone will ask you, very common interview question, optimize this Docker file. Do you already know how to do that? Question mark. How many of us already know how to optimize this Docker file? Make it a little bit faster, whatever. Do you already know this? Okay, no. Most people don't. Actually, a lot of people don't. Beautiful. So 80% don't. This was actually one thing I left when I was containerizing Backpack. And then there was one of us, someone from YouTube only, some student or I don't know, who actually optimized this when I learned, this is how you actually optimize Docker files. So there is one small thing wrong here. Is this an expensive operation? Not really. Is this an expensive operation copying from here to here? Not really. Is this an expensive operation? npm install. If I have to do Docker build again and again, will this step take a long time? The answer is yes. Abhi we don't have a lot of dependencies in package.json, but this step actually needs to hit the internet. This fourth step actually needs to hit the internet and bring a bunch of dependencies to the image, right? That is not as simple as copying files from one file system to another. That is not as simple as, setting a work directory in the image. This is an expensive operation. And the problem right now is, okay, if I change the source code even a little bit, and try to rebuild it, npm install is running again. It is not cached. मैंने थोड़ा सा source code change किया, I changed the source code a little bit. I tried to rebuild. Again, it is taking a half an hour because npm install is so slow. It doesn't seem slow right now because one dependency, but if you have 100 dependencies, this step will become really slow. So, you are changing the source code, which should not affect the npm install step. I have not changed package.json. I am not editing package.json. I am not adding a new dependency, removing a new dependency. I am simply changing the source code. If I am only changing the source code, why am I not using cached npm install? मैं npm install का cached version क्यों नहीं use कर रहा? Why can I not create another small layer maybe जहां पे सिर्फ npm install हो रहा है, जो पहले हो जाए? क्योंकि source code changes very often. This changes every second, 10 commits a day. Package.json does not change very often. Whenever you introduce a new dependency, which is once a month, let's say, or once a week, then package.json will change. Then npm install should be uncached. But most of the other times, जब आप सिर्फ source code बदल रहे हो, if you are just changing some source code, when you are rebuilding, the npm install layer should not recreate. We should use a cached layer somehow. वो कुछ hack लगाना पड़ेगा docker file में. Somehow we will have to change the docker file a little bit so that even if I change the source code, npm install remains cached. What is the assignment? Very common assignment, very common interview question. Question would be optimize this Docker file. But let's say you weren't able to reach there, then there will be a hint. What is the hint? The hint is that you have to ensure that you change the Docker file in a way that if I change index.js, if I change the source code, npm install should be cached. This layer, this step should somehow be cached. कैसे मुझे नहीं पता. But this step should be cached. Why? Because package.json did not change. Of course, if package.json changes, if you add a new dependency here, then you can't reuse the npm install stage, the npm install layer. तब तो करना ही पड़ेगा. As you can see, it is uncached here. But if I am not changing this, but changing the source code and rebuilding, I want to ensure that this step, npm install step, remains cached. ये ऊपर है किसी भी तरीके से, कैसे मुझे नहीं पता. Can you think of some first principles approach to change the Docker file a little bit such that अगर problem statement is simple, you change source code, npm install step remains cached. You change package.json or package.log.json, then of course that step remains uncached. So can you move this step somewhere? हरकीरत ऊपर move कर देता हूं. If I move it above the copy step, then copy step बाद में आया. When index.js changes, this step will become uncached. So I'll move npm install above. What is the problem here? Empty directory में npm install थोड़ी run करोगे. If you have an empty directory and you run npm install, then nothing would happen. There is no package.json. So given this Docker file, take just 2 minutes and try to think of a first principles approach कि इसको optimize कैसे कर सकते हो. How can you make sure developer की life आसान रहे? If the developer is changing source code, he doesn't have to keep reinstalling and dependencies in his Docker file. Try to think for it, another minute and a half. I'll look at Q&A until then, and then I will answer it. Any questions here? Yeah, perfect. A few people got it. Perfect. Yep, most people got it, I think. For Docker, I've changed something in source code. I have restarted container. So HMR is mildly hard in Docker. You have to use something called host mounts. I repeat, you have to use something called host mounts. There is an offline video for it. We haven't covered them yet. We haven't even covered mounts. We haven't even covered volumes. But once you understand volumes, there's something called host mounts you have to learn about. And then you just mount your local file system to the Docker container. So if you change something in your local file system, the Docker container, maybe it changes and it rebuilds. Okay, I think most people found, I don't know, Q&A, a lot of people found the answer. Docker Swarm is Docker's answer to Kubernetes or whatever, I don't know. I think it came before Kubernetes, but it lets you do container orchestration basically. We'll have a video on it. Cool, I think most people got it. Can you tell me how the guy who got placed in DevSol solved the issue? Oh, in index.js? Oh, for him it was very simple, right? He was given a source code that looked something like this. So first thing he had to do was figure out that the source code is incorrect and add this one line of code. Then he was supposed to create the Docker file. These are the two things he had to do. Then he had to do the same for 6 different languages, or 5 more different languages. But this, you could Google. You weren't expected to know C and Ruby on Rails and Go and Python. You could Google and you could fix the source code, create the Docker file. Fix the source code, create the Docker file. That was the first round. Second round was slightly harder. All right. Cool. I think most people got it, and that is right. Here, first copy package.json and copy package lock.json. Then run npm install. And uske baad copy the rest of the source code and run nodeindex.js. This is the answer to the question. कि npm install को ऊपर push कर दो किसी तरीके से, so that npm install happens first, copying of source code happens later. But of course, npm install can't run without package.json. तो पहले just copy package.json or dependency files, then run npm install, then copy the rest of the source code and बाकी सब करो. अब क्या होगा कि if I change index.js from here to here, no layer will change because copy command index.js never got copied from here to here. Index.js got copied here. So what is the benefit? Okay, now npm install will remain cached unless package.json changes or package lock.json changes, which is good. If these change, then npm install should start afresh. But if either of these don't change, but index.js changes, तो at least यहाँ तक तो सब cached रहेगा. यहाँ पे index.js changed, and then everything else follows. So now if you try to build this, one, you will see more layers because we have more steps now. So there are 6 layers now. Notice the second last command is npm install. The last command is copy. Copy is the last command. इसका फायदा क्या है कि now if I change index.js and rebuild, npm install still remains cached. Why? Because copy happens after npm install. At least index.js gets copied after npm install. So ये चीज समझ आ गई? You understand very basic optimization and one of the biggest benefits of layers. If there was a single layer, if there was no concept of building on top of other images, then even if you change index.js, आपको इसको फिर से run करना पड़ता. You would have to do an npm install again and again. But since Docker happens, or a Docker image is nothing but a bunch of layers, a lot of these layers can be reused, and आखिरी layer can change, which is not a very expensive operation. Copying a file doesn't take too long, and that is why your development journey becomes easy. Similar thing happens when you push to Docker Hub. When you push to Docker Hub, a few images get reused. So if you change this a little bit and push to Docker Hub, it will not take too much time to push to Docker Hub because a few layers will get reused. Chalo, did we understand this? Do we understand the concept of layers? We have 2 more important concepts to go through jaldi. So let's do a poll. Do we understand layers and optimizing Docker files? Yes or no? Beautiful. So let's proceed to networks and volumes. Another smart, solid concept. इसको भी problem और solution के through discuss करने की कोशिश करते हैं. Networks and volumes are concepts that become more important when you have multiple Docker containers, which you either need to persist data across. जब भी मैं एक Docker container को stop करता हूँ, when I stop a Docker container, its file system is lost. So if I start MongoDB using Docker, I put some data in it and stop it, वो data गया. That data is gone forever. That is what volumes are used for. And networks, if two containers need to talk to each other, then you need container. अगर ये क्यों, why do you need, if two containers need to talk to each other, why do we need this concept of networks? We'll see it from a problem and then we'll try to find a solution. So mota mota, eventually when you completely containerize your full stack application which has a backend, let's say in Express, and a database, let's say in Mongo, and let's say this is also running via Docker and this is also running via Docker, so this will not be able to talk to this. I repeat, from my Mac machine I can connect to my MongoDB container, but from one container I can't talk to the other container. जब मैं Mac machine में, if I go to localhost colon 27017, I go to the machine port which is usually pointed to the host port. यहाँ से मैं यहाँ जाता हूँ. But in the backend container, localhost means myself. चलो इस पे बाद में आएंगे. Volumes are a little hard. We'll come to them later. Oh, sorry, networks are a little hard. We'll come to them later. पहले volumes कर लेते हैं. Volumes are simpler. छोड़ दो इसको भी. Let's discuss volumes first. Slightly easier concept. This does not cover host mounts. Am I saying this right? I don't know if it's called host mount or something else. But basically, mounting your own file system into the container. This does not cover that. This covers a different kind of volume. There is another kind of volume that either offline video or at the end of the class I can share. There is an offline video in cohort 2, I know, which is why I know I can just share that also. Cool. If you restart a Docker container, you will notice that your data goes away. Let's see this very practically. Let me start a Docker container that starts Mongo locally. Docker run -p 27017 :27017 Mongo. I have started a fresh MongoDB container. Let me connect to the MongoDB container. Let me open MongoDB Compass. Let me try to connect to it. This is great. I have a MongoDB database where I can, or whatever, cluster where I can create a new database to-do app which has a users collection, let's say. So I have a to-do app which has a users collection. Let me add some data in here. Okay, this is the ID. Username is Harkirat. Password is 123. Let's say I connect this to a Node.js process. Node.js process is inserting data in here. Life is good. But then suddenly one day this crashes. Or I galti se turn off the Docker container. I stop the Docker container. So now will my database go down? Yes. Can I restart the database? Yes. But will the existing data persist? No. That data is lost. Whenever you are starting Mongo or whenever you start Postgres, in the end, जो आपका data store होता है, that is stored in the file system somewhere, right? There is something called write ahead logs that you might have heard of. Or generally, when you're putting data in Mongo, what are you doing? You're eventually storing it somewhere in a file. वो file अब गई. That file is no longer available because you stopped the Docker container. Docker containers are meant to be transitory. ये अच्छी चीज है. They are meant to bring up, bring down, bring up, bring down. They should be stateless. They should not persist state. जब तक चल रहा है state रहेगी. If you stop it, state goes away. Which begs the question, if I want to start MongoDB and persist data, तो मैं क्या करूं? What can I do if I want to start MongoDB? And let's say this is MongoDB running over here. Let me go into the MongoDB container. Docker exec-it. What is the ID of the MongoDB container? It is this. If I go to the Docker container, the MongoDB container, and go to the /data/db folder, the /data/db folder is where all the data is eventually dumped. Let's say for this database. For Postgres, it will be some other folder. For MySQL, it will be some other folder. For MongoDB, अंत में your data is stored somewhere over here. So can I somehow persist this folder across Docker restarts? क्या मैं कुछ ऐसा कर सकता हूं कि यार whenever I stop the Docker container, ये data कहीं copy हो जाए. This data gets copied somewhere. This folder gets duplicated somewhere. What is the benefit of this? कि अगर ये folder copy हो गया, this is the one that actually stores the MongoDB data eventually. So I can just re-bring it back in when I restart the Docker container. Can I somehow mount this folder outside the Docker container so that if the container even stops, even if I stop this container, this data exists somewhere else? And the answer is yes. And that is exactly what volumes are used for. Well, there's no good definition here, but basically, mota mota this happens. When you are starting a container, inside there is a folder which actually stores the MongoDB data. If you don't put it inside a volume, so when the container stops, this goes away. This folder is lost. But if you connect this folder to a volume, then this data persists in this volume until you delete the volume. Volumes and containers are different concepts in Docker. Images is a concept, containers is a concept, volumes is another concept. अगर आपको कुछ डेटा कंटेनर का बाहर रखना चाहते हो, so that even if the container dies, the data lives, you can use a volume for that. So I need to now mount this folder to a volume so that even if this folder dies, even if this container dies, whenever I restart the container, I can again mount this folder over here and वो data उसको फिर से मिल जाएगा. That data will persist somewhere outside the core container state. Let's see that in action. What is the first command you have to run? Docker volume create the name of your volume. So let me stop the container. As you can see, as soon as I stop the container, I exit it out of here as well. Let me stop my other container as well, जो भी चल रहा है. Let me first create a volume. Even before I start a container, let me first create this. And then when I start the container, I will mount this folder over here. So what am I doing first? Starting a volume or creating a volume. Docker volume create, let me call it db or mongo underscore db underscore data. What did I do? I created a fresh volume. ये चीज अब बन गई है. This exists irrespective of the container. ये तो बन गया. Of course, it is empty right now, but this will exist even if I stop the container. Now let me start MongoDB. Docker run -p 27017:27017 Mongo. This is how I would start MongoDB normally. But what do I want? I want कि यार ये जो /data/db folder है ना, this folder should be mounted to this volume. Whatever changes happen over here should happen over here as well. Both of them should remain in sync. So that if this gets killed, whenever I restart, I will again sync this to this guy and वो पुराना data मिल जाएगा. The state gets persisted outside the container. Container are stateless. If you want to maintain state, then you have to maintain it outside in a volume. So now if I run this, one more thing I have to do is I have to define a volume mount. कि यार /data/db of the container should be mounted to the MongoDB data volume. उल्टा होता है शायद. Let me confirm. Yeah. What do I have to say? MongoDB data जो volume है, this volume that I had just created will be mounted over here to the /data/db folder. Now let me press. So what did I change? I just added a new volume mount here. कि यार container का जो ये folder है, this folder of the container is connected to this volume. Whatever files get added over here need to get added over here also somehow. They have to remain in sync. They are the same effectively. So when I close this, data still exists here. Whenever I restart, I can still mount it to the same machine. Think of this like a database and this like a Node.js process, right? Node.js process can die, but database still persists. Whenever Node.js process restarts, it will connect to the database again. Now when I run this and I try to go to MongoDB Compass, and I try to connect, notice the user's data went away because last time I did not mount it to a volume. This time I am mounting it to a volume. So let me add a new to do app folder or database here. which has a users collection. In the users collection, let me add username. Yeah, good enough. Some data got inserted. अब वो Node.js process से insert हुआ, manually insert हुआ, doesn't matter. Some data got inserted. Where did this data eventually go? This data went to this folder, and this folder is connected to this volume. So now, even when I stop the container has went away. Docker PS, no container is running. But Docker volume ls, volume still exists. MongoDB data volume still exists. It still has the data जो इस container में पहले पड़ा था. That data is still over here, similar to a database. Now when I restart, as long as I am mounting that folder to the same volume, it will still get back that folder or that data. And if I try to connect to MongoDB again, I mean, as you can see, I did not have to reconnect only. It's still showing the data, but I can show you fresh also. If I open MongoDB Compass again, I'll see all the data here. Why? Because data was persisted over here. So what did we learn? Let me first show you all the data one more time. I stopped the container, restarted the container, but the data will still persist because I was persisting the data in a volume. This is one kind of volume. There's another type of volume. Bind mounts कहते हैं शायद उनको. I think they're called bind. I don't know. I forgot. But you know, those are for mounting your local file system to a container, which become useful for hot module reloading, which someone was asking. Okay, when you start a Next.js project that hot reloads or has hot module reloading inside a Docker container, how will you make sure that happens? तो उसमें क्या करता है, अपने file system को आप mount कर देते हो in the container. You change something in your file system, it changes in the container, container restarts, or you know whatever rebuilds. Okay, reconnect to MongoDB. And I still see the to-do app, I still see the users table. Of course, if I run it without the volume mount, then I will see no data. Then that folder is not connected. But if I run it with the volume mount, then it is connected. If I run it with the volume mount to some random, you know, folder which has nothing, then of course you'll see problems. Okay, you know, आपने किसी Postgres के data table, if you connect a Postgres data volume to a MongoDB volume, you'll see problems. So you know, you get the idea. This folder gets stored outside in a volume. Whenever you're starting MongoDB again, just connect it and you know you're good to go. आपका data यहाँ पे persisted है. Do we understand volumes? Let's do a poll. This was simple. We're sprinting through today, surprisingly. Do we understand volumes? Can we go to networks, guys? Quick poll. Let me start it. Oh, we are on. ठीक है, मतलब 87% is not bad. 88%, 86%. Like decent, not great. Let me take questions at the end, or you know, let me spend two minutes on Q&A, and then we can proceed. I'll just spend 2 minutes on Q&A, then we'll go into volumes. Volumes and Docker Compose are the two things that are left. Sorry, networks. Networks and Docker Compose are the two things that are left. Shouldn't take more than 30 minutes. So you know, we'll be able to end it at 9:45ish. Let me look at Q&A for 2 minutes, then we'll get into networks. Q&A. Is fine-tuning a model easy? I have to fine-tune Whisper for Indian accent by tomorrow. You'll find some, you know, you'll find it on Replicate for sure. I can help you at the end of the class, but you know, I'm sure there's a way to do it on some sort of an API. If they've asked you to do it on your own GPU, then that's a different question. But if you use an API, it should be simple enough. Where does backup store? What does that mean? Can we? That's a great question. That's such a beautiful question. Can we mount multiple MongoDB containers to the same volume? Can I do this? Okay, हाँ. I have mounted /data/db of the first container. Let me do it for another container. Let me start another MongoDB process. 27018. And you know, try to mount it. वैसे तो ये हुआ ही नहीं start. Probably because it was not able to, you know, get permissions on that folder. My guess is that since both of them are hogging that folder, this one second container wasn't able to get access to even, you know, get access on that container. But even if it was, you should not do it. You will run into severe concurrency issues if you have two MongoDB databases trying to, you know, update the same thing. If you want to do database applications, there are other ways of doing it. There are other ways to horizontally scale a database. Master slave architecture you might have heard of, but basically all databases should have their own memory, should have their own state. You should never have two instances trying to update the same thing in the database at the same time. You will run into very obvious issues, right? Okay, someone will, if one request goes to a database to insert a data, another goes to a database, they will try to override the file system, and you'll face problems. So I'm just thinking, is there a way to do it? Or is there any reason to do this? Okay, you have multiple containers. Whether it makes no sense to do it generally on a machine. Like if you are starting two containers, there is no real load balancing happening. The containers are running on the same host machine, right? Host machine has limited resources. तो एक container को उतनी resources मिल जाएंगी. If you start two containers, you are distributing load, but there's no point of distributing load because underlying machine is the same. ऐसे थोड़ी है, दो container बन गए तो machine बड़ी हो गई. Machine तो वही है. It's still the same machine. So if you do start two containers, there's no real benefit of load balancing, or your server can't really handle more load because it's still the same Mac machine. It won't be able to handle, just because two containers have started doesn't mean you have twice the throughput, right? All right, good question. Cool. Volumes हो गई. Networks, Docker Compose, two more things. Then we'll do Q&A and ask me whatever you want. This also comes from a problem. Okay, there is a problem that exists in Docker. Not a problem, call it a feature or a bug, doesn't matter. But there's a way to get around that feature or a bug called networks. So there should be a repository. Let's go through the repository and try it practically. What are we learning? We are learning about networks. So if I look at this repository, what is it doing? It has an index.ts file, some simple routes, I don't know what they are. Some user import from a ./db file. If I go to ./db, what does it have? It has some MongoDB code. We have already done MongoDB. Notice something peculiar here. यहाँ पे local host नहीं लिखा है, कुछ और लिखा है. We will come to why that is. But this doesn't say local host for some reason. It says Mongo for some weird reason. God knows why, we'll see. But other than that, looks like any other project. So let's say you are tasked with running this project locally. Simple task hai, nothing too complicated. Clone this repository. Let me paste it in chat and try to run it locally. Try to clone this repository and run it locally with one condition pehle. You need to start MongoDB using Docker. Just MongoDB you have to start using Docker. So let me open my terminal. Let me clone it. And notice it says week 15 live, which means in cohort 2 this was done in week 15. In cohort 3 this was done in week 25. What does that tell you? Okay, we are going really slow. And we can't really go slower than this. Then it will take 5 years to do full stack. So I think this is most optimal speed and much slower than cohort 2. Open in Visual Studio Code. What conditions did I give you? कि project को तो locally run करना है. So npm install to install all the dependencies. Is this a TypeScript project? It is. So npm run build to build all the dependencies. And then node dist/index.js to start the project. But before that, did we notice there was a slight bug here? यहाँ पे हमने Mongo लिखा हुआ था for some reason. So let's change this to localhost. Let's change this to localhost for now. So my MongoDB URL is localhost:27017, which sounds right. Now, before I start this, let me rebuild it. And before I start it, what do I have to do? I have to start the MongoDB container. How can I do that? Let me open a terminal. Run docker run 27017:27017 MongoDB container. Great. I was able to start the MongoDB instance using Docker on my machine. I can confirm if I go to MongoDB Compass, I have MongoDB running locally. So what did I do? Number one, I cloned this repository. Which repository? This repository right here, which is pasted in the chat. I cloned this locally. Then I changed one thing. In db.ts, I changed this to localhost. And then I build the project, npm run build. And before I start the project, I ran docker run port mapping 27017:27017, volume mapping, not needed, dekh lo, Mongo. I started MongoDB locally. How can I confirm MongoDB is running? If I go over here and try to connect, It indeed does connect. So now if I run node dist slash index.js, it says MongoDB connected. In fact, if I go here and refresh, I see my database is created over here. And I can play with my application. It has a users table, which is exactly what we had defined over here. A user schema, a users table. वो बन भी गया यहाँ पे. If I hit one of these endpoints, I'll be able to insert data. Let's quickly try it. There's a post and a get. Let me just try the get request for now. So if I go to localhost 3000/users, it tells me no user exists right now. And let me quickly try to add a user also. Let me send a post request. Oopsie daisy. I was trying to do some hacking before the class. I think we are clear. Yeah. So now let me try to send a post request to /user or user, and let me send it the body. What body does it expect? Name, age, and email. So let me send a name, age, 21, email, something random. Send. Seems like it worked. And if I go to my database, I can see users table has one entry over here. So my full stack application is running. But how have I run my full stack application? If this is my Mac machine, this is my Mac machine. I have started MongoDB inside a Docker container. While I was starting it, I also exposed it on port 3000 of the host machine. And I did not start index.js in Docker. I started it natively on my machine. I ran node index.js, which connects to the database over here, which is able to reach the MongoDB container. So life is good. सब कुछ सही चल रहा है. When I run node index.js on my host machine and try to connect to the database on localhost 3000, I am able to through this port mapping. If you remember, we had a port mapping over here while starting Mongo. So Mongo जब start हुआ, इसका 27017 is mapped to 27017 here. Sorry, this is wrong. 27017. And when I started this process, it started on 3000. It was able to reach the MongoDB container. Now the next question is, containerize this application. इसको भी containerize कर दो. Okay, Arkirat, that we have done. We have already containerized Docker, Node.js projects before. So let me now run this inside Docker. It is running outside Docker for sure. It is able to connect to the database. But now let me run this inside Docker as well. This also will run inside the Docker container. So what can I do? Well, you'll have to write a Docker file. I have thankfully written it for you. You're welcome. So if you have cloned this, you already have a working Docker file. It is very close to the Docker file we had written a while back for a JavaScript project. This is one for a TypeScript project. Let me just replace this with node 22 Alpine, जो हमारे पास originally थी. Same base image, working directory, copy the packages, which is, इस project का package now. ये गलत लग रहा है. नहीं सही लग रहा है. Packages. Run npm install. Copy the rest of the files. Run npm run build. So one extra step, since this is a TypeScript project, is to build the project, is to convert the TypeScript code into JavaScript code. So that is one extra step added over here. Expose port 3000, node dist /index.js, because this is where the final index.js is stored. It is not index.js anymore like we did originally. So simple hai. Slightly more, very mildly more complex TypeScript project. This is the only extra thing that is added. This is the thing that has changed because this is what we have to run now. Let's try to build it. Abhi tak I was running it like this. Now I need to run it from the Docker container. So Docker build. Let me call this one, users app. What am I calling it? I'm calling it users app. So notice again, caching आ गई. Cache workdir /app. ये layer एक दूसरे project में थी. A while back in a different project, we had the same two lines of code. So that same cache layer is being reused over here. 2 out of 6 was cached, even though this is a fresh project. But the first two lines are exactly the same, right? The first two commands are exactly the same. तो उसकी docker image की पहली दो layers got reused over here. The first two layers from there got reused over there. Other than that, copy the packages, run npm install, copy everything else, npm run build, good to go. मेरी docker image बन गई, my docker image is done. What am I doing? Slowly trying to migrate from running this on my host machine to running it inside another Docker container. Now, this was the build command. What is the run command? Docker run -p 3000:3000 user app. User app तो 3000 पोर्ट पे चल रही है, right? It is running on port 3000. So I have to expose it on port 3000. Even this Docker container that I'm starting will be exposed on my machine on port 3000, which will be, mapped to the port 3000 over here. Same as the Docker container. Port mapping मैंने add कर दी. Run. चल गया. But notice the second log did not come. Second log was MongoDB connected. वो log नहीं आ रहा यहाँ पे. This is for some reason not able to connect to this guy on what was our URL? MongoDB://localhost:27017. localhost:27017 पे why is this guy not able to connect to this guy? But अगर मैं बाहर रन कर रहा था in my native machine when I was running node/index.js, then this guy was able to connect to the database via localhost:27017. But when I run it inside this container, तो वो नहीं चल रहा है. Notice error भी आ गया बहुत बड़ा. MongoDB connection error, refused error 127.017, 127.0.1:27017. This guy is not able to connect to this guy. पहले structure समझ आ रहा है? What are the two commands I have run? The two commands that I have run are docker, copy कर लेता हूं. One is this command and one is this command. These are the two commands I ran. This first command started this. Second command started this. पहले क्या कर रहा था? Second command was replaced by node-dist/index.js. That is the only difference. Now the second command has been containerized. Why am I in this container not able to visit this container on localhost:27017? Because host Mac machine पे जब आप index.js चला रहे थे, when you were running it over here, this Node.js process is running on my Mac machine. When I write localhost over here, it means my Mac machine. But when you start it inside this container, when you say localhost, you mean this container. यहां पे localhost का मतलब है मैं, ना कि host machine. Localhost over here means myself. Am I running something on 27017? I am not. That is why I'm not able to find anything here. This is what? This is a mini machine. Mini machine has its own port range. This mini machine के 3000 पे तो कुछ चल रहा है. That has been exposed out via this port mapping. But इस mini machine पे कोई MongoDB नहीं चल रहा. MongoDB is running in a different container on the host machine. So how can this container talk to this container? Do we first understand why can't this container talk to this container? Because localhost पे, localhost does not mean Mac machine. Localhost यहाँ पे means myself. मेरा खुद का machine. And यहाँ पे कुछ नहीं चल रहा है 27017 पे. Nothing is running here. MongoDB is not running in this mini machine. It is running in a different mini machine. It has been exposed to the host machine, but it is not running on this small machine. So the question is, how can I, from this one Docker container, somehow talk to this other Docker container on port 27017? How can I do something like this? And the answer is using something called networks. So Docker has another concept called networks, which is what we are understanding this time, which is useful when you want multiple Docker containers to talk to each other. What happens is when you are starting a Docker container, you can connect it to a network. you can connect it to a network, both of them. This guy is also connected to the network. This guy is also connected to the network. And now, if you want to visit this guy, right? अगर आपको इसका डोमेन नेम चाहिए, इसका आईपी चाहिए, इसका आईपी स्लैश डोमेन नेम would be the container name of this guy. And if this guy wants to visit this guy, it can find it at the container name of this guy. ये last part थोड़ा मुश्किल लगा होगा, but basically, just like I was trying to visit it on MongoDB:// localhost :27017, localhost can be replaced by दूसरे सर्वर की आईपी क्या है, दूसरे कंटेनर की आईपी क्या है. Now that they're connected by the same network, this guy can access this guy on the domain name इस कंटेनर का जो भी नाम है. When you start a container, you can give them names. If you don't give them names, they get a default name. But when you start this, you can actually add a name argument here. कि when you're starting Mongo, I want to name this MongoDB. इस कंटेनर का नाम होगा MongoDB. तो now I can visit this at not localhost but MongoDB. MongoDB would resolve to the IP of this guy, and then this guy will be able to connect to this other container. If you ping MongoDB inside this small container, you will see it gives you a private IP, which will be the IP of this container. So this name MongoDB will get resolved to the IP of this other container when they are connected by the same network. So we have started this. Now let's stop them. Let's restart this with a name. Let's name it MongoDB. Let's change the source code over here to connect to not localhost, but connect to the name of the second container. And then let's see, does it work? And also, of course, we have to create the network and we have to connect both of them to the network. So if you go to the slides, what does it say? In Docker, a network is a powerful feature that allows containers to communicate with each other and with the outside world. Docker containers can't talk to each other by default. Localhost on a Docker container means its own network. Localhost यहाँ पे और a Node.js container means myself and not my host machine का localhost. How to make containers talk to each other? First, create a network. Just how we created a volume, you can write Docker network create, let me call it node app network. If I do a Docker network ls, it shows me node app network has been created as a bridge network. There are various types of networks. Host network and bridge network are the popular ones. This bridge network has been created. Now when I'm starting the backend process, you may or may not name the backend process. This is optional. But when I'm starting MongoDB, what am I running? Docker run, ignore -d for now. -d means detached mode, मतलब background में चला दो, but ignore this for now. Volume mount that I had, a name for my container, and a network where I want the container to be running or the created container to be connected. And then the same things. So what changes now? Will I run Docker run port mapping? Fine. Volume? Fine. Mongo? Fine. What else do I have to add? Number one, a name. Let's say MongoDB container. Bad name. You can give it a better name. But I'm calling it MongoDB container. And -- volume. Oh, sorry, not volume. -- network. Which one? Let's give it a network of, what was that network called? भूल गया. Docker network ls node app network. So now, सबसे पहले I started this network or created this network. And now, when I'm starting this guy, I am connecting it to this network. What am I saying? कि -- network equal to node app network, जो मैंने network अभी बनाया था, this guy right here. And -- name. I'm also giving it a name. Why am I giving it a name? So that the other guy can find this on that specific name. That name is how this guy will talk to this guy. Let me start it. Oh, my bad. Let me start it here in Visual Studio Code. Let me stop everything first. Let me open a few terminals and start them here. Let me open 4 terminals. In this terminal, what do I have to run? What did I miss over here? I wrote -p and -- name together. So that is wrong. पहले -- name डाल दो. That is fine. बाद में डाल दो. That is fine. -- network डाल दो. And then -p needs to come over here. That is how you start the MongoDB container. Seems to be working. Now, what is the name of this container? MongoDB container. You can name it whatever you want. I have named it this. In my source code, in my db.ts, I can replace localhost with the name of the other container. दूसरे container का नाम क्या है? Which was this one right here. मेरे पे है whatever name I want to give, I gave it this name. Now when I rebuild this, docker build, notice since I changed the source code, some of the layers will be cached, some of the layers will be uncached. Up until npm install, everything was cached. After npm install, everything was uncached. Beautiful. Now let me run it. What is the command I will run? Docker run. This was the original command that I ran. And one thing I have to change here is okay, this guy also needs to connect to the node app network. ये एक extra चीज मैंने add कर दी. What I was running before was docker run port mapping users app. What I'm running now is docker run connect to this network and then the port mapping and users app. And notice MongoDB connected, मतलब मेरी app चल गई. This app that I started, this container that I started was able to talk to MongoDB, a different container, because they are both connected to the same network. And how did this guy find the other guy? It found it through its container name. Whatever name I gave to this guy is how I will find the other guy. You can confirm that by going into the second container. If I go into the users app container and run ping MongoDB container, it gives me back a private IP, which is the IP of the other container. That is how I am finding the other container through this network that we have connected them from. So this is similar to a domain name. जैसे localhost is a domain name, google.com is a domain name, and similarly MongoDB container now resolves to an IP inside this other container, this one right here. Why? Because they are connected by the same network. So do we understand this? Let's do a poll. Do we understand how can you start 2 applications that can talk to each other, both of them inside Docker containers? थोड़ा 78%. All right, let me do another recap. मैं starting से start करता हूँ और फिर से खत्म मारता हूँ. Slides are the best way to look at it वैसे, but हमारा कोड क्या था? The original code that I had, let me close everything. Simple, एक index.ts file and a db.ts file. Very simple MERN stack project, literal MERN stack, MongoDB, Express and Node.js. React नहीं है, just the backend. We created a Docker file for it. We built the project. How do you build a project? Docker build -t, name of the project, users app, and dot. I was able to build an image for my TypeScript MERN stack application. Beautiful. But when I was starting it, right, Docker run -p 3000:3000 users-app. When I was starting it like this, port is already taken. Let me stop everything. Let me stop all the containers. When I was starting it, I noticed second log नहीं आ रहा है. यहाँ पे एक log आना चाहिए because in db.ts I have logged MongoDB connected जब भी MongoDB से connect हो जा रहा हूँ. But this log wasn't coming when this URL was localhost. Why was that happening? Because when this container was trying to, this is how we were doing it. We were starting 2 different Docker containers. One was a MongoDB container. One was our users app container. This is the users app container. This is the MongoDB container. When I was visiting localhost here, it was not able to connect to this guy because localhost का मतलब यहाँ है मैं, मेरी machine, this machine right here, the mini container. So how did we fix it? We learned कि Docker has this concept of networks. अगर आपको दो containers को आपस में बात करानी है, if this container needs to somehow discover the other container, you can connect them via a network. What did we learn? कि a network, or more technically a bridge network, which is what we are doing right now, lets multiple Docker containers find each other, discover each other through this network. So to be able to facilitate that, हमने क्या किया? Number one, we started MongoDB by running this command. The extra thing that we added was a name, which we called, let's say, MongoDB, or you can call it MongoDB container, or you can call it whatever you want. We added an extra name and we added a network. Yeah, this specific MongoDB container needs to be connected to this users underscore app underscore network. These are the two extra things that I added while starting the MongoDB container. And similarly, while starting the second container, while starting the Docker container, this one right here, I ran -- network users app underscore network. So the only thing that I changed was that I added or connected both of them via a network, and I changed localhost. I changed this to be the name of this container, which in this case is MongoDB container. So I'm now trying to visit it not on localhost, but on the name of the other container. And when I went into this container, I also saw that MongoDB container indeed resolves to the IP of something else, which in this case is the IP of the other container. So what did I change? This is the command that I ran. I gave it a name. I gave it a network. This is the command that I ran. I gave it a network. Before I did both of these, I ran another command to create a network. I repeat, I ran a command to create a network. Docker network create users underscore app underscore network. पहले मैंने ये network create किया. I created this network. Then when starting this guy and starting this guy, I gave this guy a name. I gave this guy a network. And when starting this guy, I just gave it a network because this doesn't need to discover this right now. MongoDB doesn't need to find Node.js. Node.js needs to find the MongoDB process. So, that is why I did not give this guy a name. Now this guy can discover this guy on the name of the second container, which the name is this thing right here. So I replaced localhost with MongoDB container and everything worked because this guy was able to find the other container. Let me look at Q&A for another minute and see if anything else is needed, or if there's any doubts. Can we connect Docker containers to network after creating them? Yes, you can run Docker network connect, name of the container, name of the network, name of the container. Where is volume stored? It will be stored somewhere in your, you're asking where is volume stored in Docker? I have no idea, but probably somewhere in your Docker file system registry, जहाँ पे भी आपके machine में Docker is stored is where it will be storing. So this volume will be Docker desktop folder. It will be somewhere in your C drive, exactly. So this volume will somewhere be in your hard disk. But most probably it will not be, it will be owned, it will be in a folder somewhere owned by Docker. Network नहीं समझ आया. What happens when both containers run on different servers? Then it's a different thing. This is all for local development. Network benefit for local development. जब एक machine पे दोनों चल रहे हैं. If they're on different machines, then like there are a bunch of things that happen. Like simplest thing that will happen is that this is machine 1, जहाँ पे you're running Node.js, doesn't matter in a container or not. This is machine 2. Where whatever it is, another container called Mongo. and this machine is ec2-1.aws.com, and you expose this on the host machine. So यहाँ पे the URL will be this. This guy cannot find localhost. Localhost इसको यहीं मिलता है, but it can find public-facing URLs, right? If you host this on EC2 something something something, then this guy will be able to, through your routers and networks, be able to reach this machine from where it will be routed to the Mongo container. So it's a much simpler challenge if you have multiple machines and not just one machine. Can I define path for volume? You can define whatever you want, right? Like wherever you want your, I'm assuming you mean this. I'm assuming you mean what this path needs to be here, and you can put whatever you want here. Whatever you put over here will be mounted into that container. वहाँ पे उस folder में, container में, इस folder में जो भी present है will be the same as the one that's present in this volume. समझ आ गया? If you're given name of the backend running the Docker container, would it be accessible to the host machine? No. Host machine is not connected to the network. So host machine cannot, access it on the name of this container. It is for amongst these containers, they can talk to each other given a name. I don't think host machine can. I can try, but pretty sure that doesn't happen. Let's do a Docker run. Let's start MongoDB again. Let's name it something else. I'm going to name it MongoDB container 2, but 100% sure this does not happen. Just confirming it for you. I started it, I named it Mongo container 2. If I try to go to Mongo container 2 2717, nothing happens as expected. Chat, sorry, Q&A. Docker Compose को introduce किया है. We're coming to that soon. Did not understand network. Network is the same as a virtual box we used in it. I don't understand this question. Why are we exposing Mongo port on the Mac? We don't need to do that. That is a beautiful question. Okay, now we no longer need to have this port mapping because we don't no longer need this because we are not accessing MongoDB from the host machine anymore. We are accessing it from a different container. So you can remove the port mapping. It is not a container, like it's not a Docker container. A volume is not a Docker container. It is actually storing data for you. It has different properties than what a container would have. We'll probably not do like Docker Compose today. We're at 9:44. I can do a quick, I quickly try to take you through it, but most probably I'll have to do it either next week or in an offline video. We will cover Kubernetes and Helm. Go to blog.handexers.com. You'll find the syllabus. We did not discuss Docker Compose. And we'll probably will not. We're at 9:45 already. So when we build an image of an app, do we build multiple containers or just one container? We are building an image. You are not building a container. Container is an image and execution. There are different things. What you are building is an image. Now an image can have a Golang project also, a Node.js project also. It can have 10 different projects. वो आप पे है कि आपने image कैसी बनाई है. And if you want to start, you can also start multiple processes, a Go process, a Rust process in your final command that you're running. So that depends on you. A single container can start multiple processes on different ports. But when you're creating an image, you're not really creating multiple containers. You're just creating a single container that will start when the image is started. Include an existing image while creating an image of your application for both others to install it. So can we include Mongo image and then install Node instead of doing network? Yes, you can do that. You can start MongoDB and your Node.js process in the same container. I would not do that though. You will need 10 different processes eventually. You will need, the point of this containerization is that eventually you will deploy this somewhere on Kubernetes or, ECS. Kahin pe you are going to deploy this eventually. So when you are deploying your backend, you don't want to deploy your backend and MongoDB together. MongoDB तो अलग से hosted होता है. ऐसा थोड़ी होगा कि जब भी आपका backend is coming up, a new MongoDB is coming up. तो you don't create Docker files that start both MongoDB and both Node.js process together. Your goal isn't to create, I mean, you can probably for local development, but you never deploy that. So the Docker files that you create are independent for MongoDB, independent for your Node.js process, and you don't merge them. Even though you can, it seems like you found a way to get around networks. But you no one does that. You shouldn't do that. You should understand networks and start them separately. Can we have Mongo running on a router, as in on the intranet of my Wi-Fi and connect from multiple laptops? Yes. Why can you not? It's just a process that is exposed on a port on your machine. If other people in your whatever hostel or room or intranet can access your machine, they can access your Node.js process, they can access your Rust project, they can access your MongoDB cluster, whatever you want. But we expose the public IP in that case, correct? Yes, so this doesn't happen. Okay, I'm assuming you mean in this case, okay, yeah, bruh. Okay, I don't know where all the content is, but I am assuming you mean in this case, okay, you have a separate machine where you have a Node.js container running, and you have a separate machine. By the way, like I think class is over, and if you want to drop off. Docker Compose, I'll do offline video or next week. Let's not do Docker Compose today. It'll take at least 45 minutes, so it will extend too much. All right. So what I was saying was, if it's on a separate machine, and you're running MongoDB here in a container, this guy needs to talk to this guy. So yes, you will have to expose this guy's URL. So what you should do is you should, number one, there are a lot of things you can do. For example, one thing is you can expose the URL publicly, but you can add some sort of IPs, whitelisted IPs over here. This container can only be accessed, or this port can only be accessed by a specific subnet. आपने मान लो जहाँ पे भी आपका backend host किया हुआ है, only that guy can talk to MongoDB. So that way, even if your URL is, public, people can't really visit your process, touch your process, because you have a very heavy firewall that is only allowing traffic from your own backend and nowhere else. That is one thing you can do. Other thing is, you have what's called a VPN, or you have a Kubernetes cluster where all of these are connected via an internal network. You're a bunch of these machines, and this machine is only accessible inside the intranet or inside the VPN. And no one outside can hit this. People outside can hit the backend. People outside can't hit this. So that way, they can connect. Eventually, when we create a full stack application and deploy it in Kubernetes, you will see this. Cool. So yes, even though you are exposing your URL over here, it has upsides and downsides, and you can optimize it by adding firewalls. Cool. After removing the port, can we access MongoDB with MongoDB Compass? After removing the port, no, you can't. Then you can't with Compass. Compass is running on host machine, right? So if you want to access it via Compass, you have to have the port mapping. If not, then not. Harkit, I have Python backend, React code frontend is already deployed on Python backend, but I want to deploy on AWS using ECR. I mean, that's very simple. Just go to ECR, create a new repository, and when you're doing a Docker push, just give it a Docker push to ECR. That's the only thing you need to change, right? How do you push to not Docker Hub, but to your private registry? This one uses, there you go. Yeah, just just tag your image, or when you're building your image, name it something like this. You'll find this in your AWS account wherever you have created ECR or ECS. Wherever you have created your container registry, wherever you have created your container registry in ECR, it'll give you a URL like this where your container registry is hosted. Tag your Docker image with that, or build your Docker image with that name and push it. You will also, of course, have to log into Docker. So unsure how you do that in for AWS, but I'm sure there's an easy way. Log into Docker ECR. Yeah, basically, one of these blog posts. let's see, AWS ECR, get login password, Docker login. There you go. So, just get the AWS CLI, put your credentials in there, run this command to get your login password to ECR, and then do a Docker login, and username is AWS, password is whatever you had. And then, this is the host name, and then you can push. So let me post this in chat. But like changing the registry is simple. If you want to not push it to hub.docker.com, wherever you want to push, just log into that specific registry and push. Class is over, you can leave. How to make curvy lines in Accelerator? Boy, that I don't. I mean, it's a beautiful question. How do you make curvy lines? It will just involve a bunch of physics. What is this? It's like a line on. So it's like last two of these, this line and the line before change a little bit based on how I'm moving the pointer. Second one is easy. It's just a straight line. I think this is the starting point. This is just a straight line from here to here. Yeah. But इससे पिछले वाली is dependent. उसका curve is a little dependent on your output, where you are. So I'm sure there's an easy way to quantify this and, brilliant. Actually, I don't know. This might not be very easy because this is no longer a line. It's a curved shape. So maybe there's an easy way to do it, like Canvas provides you something, but if not, then this is probably an arc. Jiska, that is changing. The second thing is a line, and the first thing is an arc whose, whatever angle is changing. So it's like a circle, I think. I would assume. Not a circle, it's like an oval, but ठीक है, मतलब वही थोड़ा first principle से करके करना पड़ेगा. Yeah, continuous running on different machines, there's no easy way for them to communicate, right? If you are running something on your machine, and irrespective of in a Docker container or not, if there are separate machines, then you have to expose, this is in US and this is in India. Doesn't matter if you're running MongoDB here inside a Docker container or not. You have to expose it over the internet, right? So people can see it, people can visit it. So there's no internal networking that you can do using Docker so that this India machine is able to talk to, this US machine through some internal network. You have to go through the internet. You have to expose this on the internet, and you will get it. Basically, it doesn't matter Docker or not. If you have two different machines, for them to communicate, this needs to be exposed on a public IP, a public domain name that this guy will visit from. Repeated questions. Can you give a recap of the volume command? Yeah, so there are two commands. One to create a volume. That's Docker one second. What date is it? Cool. Yeah, what I was saying was there are two commands to know. Check my screen. The first is Docker volume create and the name of your volume, which in our case was MongoDB data. You can name it whatever you want. And the second one was whenever you're running a container, you can provide the volume using -v. Okay, this is the volume that I want to store my data in, and this is the internal folder जिसका data मुझे यहाँ रखना है. So that's how you create a volume. That is how you use a volume. You were creating a network or a bridge between Mongo container and Node.js container, but can we have a container where both? Yeah, exactly. Someone else has the same thing. You can do that. The problem there is that databases are supposed to be, not transitory. They should not go up and down. They should be persisted always forever. You should not have two instances of MongoDB running, but you can have multiple instances of Node.js process running. So even though you can do that, someone else has the same thing. And you can get around networks. What will happen is that Docker file will be sort of useless for production use cases. You won't really be deploying a Docker file that starts both Node.js and MongoDB at the same time. So that will be a slightly useless Docker file. It will be good for local development. But for local development, you can just use Docker Compose, which we are running. We're about to learn, but we'll learn eventually. That will get away with all of this complexity of creating networks. You still need a network there, but you don't have to manually create it. It creates it for you. So Docker Compose sort of solves this a little bit. If you don't want to get into the complications of creating a network yourself, you can create a Docker Compose file which represents all of your services: MongoDB, Redis, Node.js process, Rust process, and in a single command you'll start everything. They'll be connected via a network, and you will not have to worry about writing all of these commands yourself. That is a better way to do it than starting both of them in the same file. How do you know this volume is created by previous developers? A developer who had created left and you ran Docker again. How do you identify volume command has been run? Oh, I mean, you can just run Docker volume ls, right? To see what all volumes have been created. And if the specific, how to identify volume command has to be run. So first things first, you do all of this locally. Rarely will you create MongoDB in production in a Docker container mounted to a volume. You will usually not do that. If you are running MongoDB in production, you number one, most people don't do it. They delegate their databases. If you have to, you will run it directly on the host machine. You will not run it inside a Docker container. And you will not be like this. This would be very dangerous if one developer is creating a volume and then other developer is SSHing to a production machine and figuring out what that volume is and trying to connect it. But let's say that is happening in your WoW. So what I would do is I would just reverse search. If that developer is gone and he's not telling me anything, then I will reverse search and figure out what all volumes are already there. Start a container mounted to that volume. Try to explore the volume and then figure out which volume is and start it over there. If that was your question. I don't think I understood your question very well. I would suggest a Mac. How to skip build errors in Vercel? There is a flag. I forgot. Google it. But there's one flag that you can set, and that does not skip build errors. But if you have lint errors or warnings, it'll still deploy an application if you have warnings. But if you have build errors, then you have to fix them. I'm picking them from Q&A, but I think I'm very behind. So let me just open chat, and you guys can ask me questions there. As I said, the class is ended, so feel free to drop off if you have no questions. All right, a lot of questions. We are going to cover Kubernetes and Helm. Just go to the official syllabus, you'll find it. You probably require some niche skills or tech stacks that are easy to find. So what do you think that Stack 2025? Or is it going to be Rust, or is it going to be something else? How do you enter Devin, or the tech stack that we select you on, and the edge did you have the others? So two questions there. First question, that is not necessary, which I've learned by Karan. Karan had very basic skills, but basically did not have a niche skill. Still was able to get such a high offer. So maybe it is not just a niche skill that you need. But if I had to choose one today, it would be somewhere related to AI or browser automation, or basically I'd look at companies first. Yeah, ye company sahi lag rahi hai, and what that company needs, and a lot of them, even for niches in the past, it's not like I learned that niche end to end बहुत ज़्यादा, but I learned one very specific use case so well. Okay, it was a very easy. Not a lot of resumes that reached them had that specific skill. A good example of this is WebRTC and SFUs and MediaSoup, that specific library that not a lot of people knew about. So whatever that library is today for an AI framework is what I would pick, and get really good at it, maybe start contributing to it, become one of the biggest contributors there, and then it should be easy from there. Devin was, I reported a vulnerability through which I got in. So if you go through my Devin video, the one that I created, while I was in it, in the middle I found a vulnerability. It was triaged as a medium severity one, and then they just asked to join. So my role is primarily helping with that and a bunch of other things. Can you help me with this? Hold on. So I can't, basically, I have never trained Whisper locally myself. But if you want to use let's see, Whisper, train, replicate. Fine tune and love this, isn't it? train, I mean, I would have to go through the same effort as you. I've never done this before, so I'll just Google and try to figure this out. Model locally. It seems like there's a guide. You have MP3 audio that you fetch from YouTube, let's say. You give it to Whisper, it transcribes it, does through a sentence transformer, creates a transcript embedding, which you store in Python. तो पूरा RAG process है. How do you वो YouTube video को, how can you talk to a YouTube video? Question wasn't that. Question was, this is running it locally. This isn't training it locally, but there you go, training your own model. Possible to train Whisper with my own data set in our system. We are limited by C64. Check out this blog. There we go. And what is this? Repo where publish it. So far, hey, could you point it? Okay, try this. Pasting it in chat. Step-by-step guide on fine-tuning Whisper for multilingual ASR datasets using Hugging Face transformers. Let's see. Oh, bhai. Can't say it is as easy to digest as I would have hoped. But a few commands. Log into Hugging Face. Import load dataset. So where are they getting the dataset from? Somewhere from Mozilla, it seems. Print the dataset, a train and a test dataset. So one for training and one for testing. But like, where are they getting all the audios from? What is this? Mozilla Foundation / common volume. Okay, it is a dataset which has probably a bunch of audios that you can train it on. Cool. So the first question is, do you have these data sets that you are going to train the model on? And if you do, then it seems like, I mean, depending on where you need to run this eventually, you can go through this blog post and try to understand it. They got two specific split test plus validation and split equal to test. So I'm just interesting, so I'm reading through it. What does split equal to test plus validation mean? It probably means you need to split this into two parts, one for training the model, one for validating the model. I don't know what validating the model means and how it's different from testing the model. But you get like an array of volumes to train from and then an array of volumes to test from. This is your data set that you're going to train the model on. Then only provides input on samples. Common voice samples contain additional metadata information such as accent, locale, which can be used to discard for ASR, keeping the notebook as soon as possible, only to consider the input output and translate, surrounding discarding data. So it removes a bunch of these things. Okay, is specific volume, voice की वो क्या है, data, date क्या, age क्या है, वो क्या है, सारा मेरा data निकाल देता है. Only based on the volume or the current बंदे का accent, without any features described over here, does it want to train the model. Prepare the future extracted tokenizer and data. भाबरे तो बहुत लंबा है. Feature extractor equal to Whisper feature extractor dot from pre-trained OpenAI / Whisper small. Input string equal to common voice of train of 0 dot sentence. Labels equal to tokenizer dot input stream dot input IDs. This line I don't know what it does. Decoded with special tokenizer dot decode labels. ये पढ़ना पड़ेगा, ये एक्चुअली मतलब रन करना पड़ेगा भाई locally to. Oh, there you go. Input is this. खीर को मिठास पर something. Decoded is okay. It just converts it into a format that the model understands. That is what these are. It's different for code. It's different for whatever they are doing here. Decoded without special looks like the same thing. R equal to true. Basically भाई इसके through जाओ, मतलब मैं भी जा ही रहा हूँ, but try to run it. And the question really would be basically run all of this for their data set. Basically, if you go through this all ऊपर से नीचे तक, then you should be able to train it on that Mozilla data set. And then the question is, how do you create your own data set? How do you publish it to Hugging Face and use that for doing this? So I would actually be interested if you can write a better blog post on how to run this locally, and I can go through it in the next class. So try to do it yourself. You will have to do it yourself only, but try to do it. And even if you don't get a job, like I would personally be interested to see how do you do that? How do you train your model? So even we are also using a very external service called 11 Labs right now for doing this. So if you can find a way to do this elegantly, it might just be useful to me as well. So maybe try to go through this. I've not posted the URL, this is the URL, and you can go there. All right. Notion doc, very good question, by the way. Very interesting. Makes you think. And I'm not surprised that people have this as an assignment somewhere. If I get an HTTP server to host a backend server, suppose a render, then how is it handling request response? Every time a new user hit, or if it is handling, yeah, that's a beautiful question. Yeah, so these are what are called serverless deployments. So it's not like there's a machine that's doing an app.listen. Everyone has their own implementation of serverless. AWS uses something called Firecracker to start a bunch of small virtual machines whenever you hit a Lambda function, and similarly render, and similarly Cloudflare workers. They have their own way to scale. These mini machines. Okay, if there is not a lot of load, there are 0 machines. But if someone hits your server, there is one small machine that starts, or small container that starts, and how the traffic reaches that container. And if a lot of people come, then they start a bunch of these small containers. So yeah, every cloud provider has its own way to do it. It's not this, but the most interesting one and the most publicized as to how it is done it. I mean, even Amazon has written, I think, a blog post on how they've used Firecracker in Lambda. But Cloudflare workers, and we'll go through them, eventually in the cohort as well. But if you go through cohort 2 slides on Cloudflare workers, you'll just go to project.hynixer.com, find the slides. There is a slide on how, how they are scaling workers, why their workers are really fast and, lightweight, and how they have process isolation between workers without having to spend a lot of resources in starting a server and stopping a server. So not a server, like a process. So yeah, it's a brief of how serverless deployments work, which is what happens on Render and Cloudflare workers and AWS Lambda. Great question. Can you show we will understand Docker Compose eventually, so I'll take you through it then. Do I have my hands on one right now? I don't know if CMS has CMS is not a monorepo, but it's daily code a monorepo. Docker, it does have a Docker Compose, so there you go. Let's see what it has. This is the main app, this is the database, and is there anything monorepo specific over here? And I think the answer is no. If you look at the Docker file, it's fairly simple Docker file. The only thing that's different is, we have this dev Docker command in package.json, which probably, under the hood is, it's also not doing much. npm run dev, or just running npm run dev globally. Yeah, so that might change. Like right now, this monorepo only has one app, apps/web. But if you have multiple apps, then it'll change over here. I'll probably put multiple scripts for multiple apps, dev web, dev backend, dev frontend, so on and so forth. And every Docker file will, start one of them. Cool. Notion doc. I built a Docker Compose for frontend Next.js backend Django DB. Issue is when I call the API from my server in Next.js, API will work well for the container IP address, but the same API in a different container internal service name backend is not working, but same API. Basically, when I calling from server side API, getting call internally, but when I call from use effect on the client, it needs to change the IP address. Exactly. So what would you do here? You need to expose the backend somehow on the internet, right? And that is the URL that you need to use everywhere. You can use that URL everywhere. I get what you're trying to do. You're trying to make sure, okay, whenever the Next.js process is hitting the front end is hitting the backend on the server side. That means the front is being built, or there is static site generation. That happens on the server, but unfortunately, there's no way for client to proxy request somehow to your backend without the backend being exposed on the internet. So you will have to expose the backend on the internet unless you have an application that never talks from the client to the backend, and only the on the server the client talks to the backend. Only then it will work. Otherwise, अगर आप कि user को अपने browser से request भेजनी है, तो the backend needs to be exposed on some sort of a URL. You can't internally communicate from a browser to a server somewhere. All right, a lot of Notion docs. Let's go through them. Let me come to projects later. Let me answer questions first. Is this just update doc? Oh no, this is the questions. So I don't see anything for today, but I don't know. I think a Mac and M2 or M3 should be fine. Why do we have a need or even Docker? Can rely on prod data in this? What do we scale up and how does Docker handle volume caching? So specifically in our case, we were running databases locally, in which case it's a good thing if the container dies and comes back up, the data is still there. You will never use it on production. You will never have a database running inside a machine where your volume mounted to a server on that machine. Databases, if you are self-hosting, will run directly on the host machine. So this isn't a challenge or something you should do in production to start a database and have a volume mount somewhere. Yeah. What is this? Oh, that's pretty good. How is the question? Like, what do you get? What features do you train the person or whatever? But yeah, project is pretty good, very flashy. But I would just be curious to know what parameters are you judging people on? Cool. Very cool. I like it. You have a front end as well, which is good. Not a lot of people have that. All right. What network are you on? Maybe actually doesn't matter, but this is pretty cool. And where claim record? Beautiful. This is very good. Exactly what was needed. Where is your repository? Taking contract source. Yep. Very cool that you've deployed it and everything. And stay. Yeah, looks perfect. Nice. Beautiful. Yeah, that's how you would do it. Yep, perfect. This is great. Very nice. Probably the first full end-to-end implementation that I saw of the project. Very cool. Yeah, we'll probably, whenever we get hands-on, eventually we'll do this. Otherwise, there's a cal.com video on my channel where I set up cal.com. You can look at that. Not just process 150 MB. There are alternatives for Docker, better efficient memory usage. I don't think 150 MB is too bad for what it gives, considering it's giving you a file system and the Node.js runtime and everything. There are alternatives to Docker. There's one called Podman, but unsure if it will solve this specific problem for you. It uses less spaces. Yeah, that is a alternate to Docker. It's also a container creation and container runtime technology. I've never used it. I've heard a lot about them because they market themselves as whatever, replace Docker. But yeah, basically same thing. I just got to know smart contracts be written in Python using Seahorse. Yeah, someone was trying this. I don't think this is super maintained. This developer was also very weird. Like he never took a grant, even though he was offered a grant, but I think he wanted to stay anonymous or something. I think the developer is also a woman. I could be wrong, but I think that was the case. Yeah, I don't know how much of that is built or not, but it doesn't. Yeah, that's right. You can build, like anyone can write any wrapper to build a Solana contract in, and I think there's some efforts to add a Zig contract library as well. But right now, no, most people write in Rust only, even though you can write it with C and with this guy. Someone tried this for TypeScript also. But in the end, Rust is what most contracts are written in. Why you not integrated months ago? No reason other than it being a little scary, considering it requires private key to be stored on the server. But other than that, productionizing is so hard, and especially something like this, which can get a little risky. But you are right. I mean, there's no real excuse here. Like I've just been lazy. No reason other than that to not do it. Other than if there's a vulnerability, I'll lose real money. But that can be I can get around that by not having too much money in that wallet. So I should probably do that. Cool. Done, 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 done. How can we config container spec? That's a beautiful question. Can you resource limit a Docker container? I think the answer is yes. I'm forgetting how. You can definitely do this for pods in Kubernetes. Can you do this for containers in Docker? Why do I have a feeling you can? Docker container limit resources. It feels like I did this a while back when I was trying to create lead code back in 2018. Yeah, resource constraints. By default, containers have no resource constraints, but if you want, how will you add them? Okay, seems like the maximum amount of memory the container can use. There you go. So you can pass in, arguments like dash memory, which represents limit a container's access to memory. A Docker container can enforce hard or soft limits. Hard limits let the container use no more memory than a fixed amount of memory. Soft limits let the container use as much memory as it needs unless certain conditions are met, such as the kernel detects low memory on or contention on the host machine. Great. So you probably want to use soft limits. If the machine is not constrained already, then you can run it. But if it is constrained, then you have a limit that you can't cross. And what else can you limit? There you go. You can limit CPU as well. Dash CPUs. Great. So there's easy way to do it. Yeah, and by default there are no remote resource limits, but you can enforce them. That was a good question. What else did you have done?